There is a food so ancient that the pharaohs of Egypt wanted it beside them in death. A small underground tuber, once valued enough to be carried into the afterlife, once trusted enough to help sustain civilizations for thousands of years. And yet today, across the modern agricultural world, that same plant has been reclassified as something dangerous. Not as a crop, not as a survival food, but as one of the worst weeds on earth. Agricultural departments issue warnings about it. Technical bulletins describe it as a menace. Chemical companies sell herbicides designed specifically to wipe it out. An entire system has been built around teaching farmers how to poison it into disappearance. That is the contradiction at the heart of this story. How does a plant that produces abundant food, survives brutal conditions, and asks for almost nothing in return become an enemy of modern agriculture? To understand that, we have to go back to the beginning. In the early 20th century, archaeologists excavating pre-dynastic Egyptian tombs uncovered something unexpected. Not only jewelry or treasure, but carefully dried tubers placed beside the dead. These were not random scraps of food. They had been selected, prepared, and preserved on purpose. Even more striking, researchers later found the same tubers inside the stomachs of mummies. The dead had eaten them as a final meal, and the living had placed them in the tombs to sustain the soul beyond death. From the very first moment it appears in the historical record, this plant was never treated as worthless. It was treated as essential. What makes that discovery even more astonishing is how far back the story really goes. At Wadi Kubaniya, north of Aswan, archaeologists found wild roots of this same plant dating to around 16,000 BCE. That means human beings were gathering it during the last ice age, thousands of years before agriculture, in the form we usually imagine it, had even begun. Long before fields were organized, before grain became the foundation of settled civilization, people already knew this plant was worth seeking out. It was not an accidental part of the diet. It was one of the earliest foods humans deliberately returned to again and again. By around 5000 BCE, it had moved far beyond simple gathering. In Egypt, it became one of the oldest cultivated foods in the entire civilization, ranking only behind emmer wheat and barley. That detail matters because it shows this was not some minor supplement added on the side. It was a foundational food. It stood near the center of an agricultural world that would shape history. Its importance appears again in the tomb of Rekhmir, vizier to Pharaoh Thutmose III. Wall paintings there show workers measuring these tubers, grinding them with long pestles, mixing them with honey, and shaping the mixture into tall pointed cones. These were sacred cakes prepared as offerings to the god Amun, made according to royal decree during religious feasts. In other words, this plant did not live only in kitchens and storehouses. It also entered ritual, ceremony, and the spiritual life of the civilization, and Egypt was not alone. The Greeks knew it. Theophrastus wrote of boiling it in beer. The Romans traded it. Later, Arabs carried it across North Africa into Sicily and then into Spain. In Valencia, it became the basis of horchata de chufa, a sweet, cold, milk-like drink that has been made there since the 13th century and is still produced today. For thousands of years, this was not a forgotten plant at all. It moved through empires, across cultures, and from one age to the next without disappearing. So the real mystery is not why ancient people valued it. The real mystery is why the modern world chose to stop. The plant at the center of this story is chufa, scientifically known as Cyperus esculentus. In Spain, it is called chufa. In parts of Africa, it goes by other local names. In English, it is often marketed as tiger nut because of the striped skin of its tubers. But that name is misleading. It is not a nut at all. It is a tuber, an underground storage organ built to hold energy and keep the plant alive under harsh conditions. That distinction matters because from the beginning, chufa was never just another seed or grain. It was a food designed by nature for resilience. Chufa belongs to the sedge family, the same family that gave the ancient world papyrus. It grows in marshes, wet soils, in places where many ordinary food crops would simply rot. Its stems are triangular, and beneath the surface, it spreads through a network of underground tubers. One plant can produce around 75 of them. Each tuber is small, roughly the size of a chickpea, but packed with stored energy. Their flavor is naturally sweet and nutty, often described as something between almond and coconut. Ancient Egyptians used chufa in several ways. They ate it raw, roasted it over fire, boiled it in beer, or ground it together with honey. It also appeared in ancient medicine. The Ebers Papyrus, one of the oldest surviving medical texts, records chufa-based mixtures for mouth treatments and fumigations meant to sweeten the smell of houses. That detail reveals something important. Chufa was not only a staple food, it was woven into daily life more broadly, appearing in both nourishment and healing. But its greatest strength may have been neither taste nor versatility. It was storage. Chufa could be dried and kept for years without refrigeration, without preservatives, and without chemical treatment. Once dried, the tubers remained stable. When needed, they could simply be soaked in water for a few hours and would swell back, ready to be eaten or planted again. That made chufa far more than food. It made it a form of survival technology. People could harvest it in one season, dry it through the winter, and rely on it during famine, drought, or siege. In a world where food security was fragile, that kind of reliability was priceless. If a food could survive for years, feed people in hard times, and return almost ready for life again the moment it touched water, then what exactly made the modern world decide it was a problem? Once you look inside chufa, the contradiction becomes even harder to ignore. According to the source text, chufa contains up to about 10% protein, a level comparable to many grains. But unlike many plant foods, it is described as containing all essential amino acids. Its fat content is also unusually high, mostly in the form of healthy unsaturated fats such as oleic acid, the same type of fat found in olive oil. In fact, the oil yield is so significant that researchers have even explored chufa as a possible biodiesel crop. That alone tells you this is not some nutritionally empty weed surviving on the margins. It is a dense, functional food. Its carbohydrate profile makes it even more remarkable. The source explains that chufa's carbohydrates are primarily resistant starch, which feeds beneficial gut bacteria and does not spike blood sugar in the same way ordinary starch does. It is said to contain twice the starch of potatoes while having a lower glycemic impact, offering steadier energy without the same crash. On top of that, it is rich in fiber, with the text describing its fiber content as nearly 4 times higher than standard fiber sources. It also contains important minerals including calcium, magnesium, iron, and potassium. And then there is its flexibility. Chufa is naturally gluten-free, dairy-free, and friendly to many people with common food sensitivities. It can be ground into flour, blended into milk, roasted for snacks, or eaten raw. So by this point, the central question becomes impossible to avoid. If this tuber is so nutritious, if it sustained people for thousands of years, if it survives drought, stores for long periods, and requires so little external support, then why is it not one of the major staple crops of the modern world? Why did wheat, corn, and soy take that place instead? That is where the story turns from history into conflict. The answer given by the source is blunt. Chufa could not be controlled. And once that became clear, modern agriculture declared war on it. In its wild form known as yellow nut sedge, it is now officially classified as one of the world's worst agricultural weeds. Not a minor nuisance, not a manageable inconvenience, one of the worst. Agricultural extension offices publish warnings about it. Universities study how to kill it. Chemical companies develop herbicides aimed specifically at stopping it. The source even points to a USDA technical bulletin dedicated to yellow nut sedge, describing it as a menace in the Corn Belt. Federal resources were spent learning how to destroy a plant that had once fed pharaohs. The reason is not difficult to see. Chufa spreads through underground tubers. You can kill the visible plant above the soil and still fail to destroy what matters below it. One plant can produce around 75 tubers, and each one can survive in the soil for years. Once established, it becomes extremely difficult to eliminate completely. But that is exactly the trait that made it so valuable for most of human history. Its regenerative power, its resilience, its refusal to disappear, those were once signs of abundance and security. In the logic of industrial farming, they became signs of danger. The source lists a whole arsenal of chemicals used against it, including glyphosate, halosulfuron, sulfentrazone, and bentazone. Research papers, it says, admit that a single treatment often fails, which is why repeated treatments are recommended year after year just to achieve partial control. That detail reveals something deeper than a fight over weeds. The real threat was never just competition in the field. The real threat was what Chufa exposed. Modern commodity crops need near-perfect conditions, constant inputs, chemical protection, and massive infrastructure. Chufa does not. It grows, survives, and produces food with a kind of independence that industrial agriculture does not know how to profit from. If the system was willing to build an entire chemical war around this plant, then the next question becomes even more important. Who actually benefits from making people fear a food that once kept civilizations alive? According to the source, this is where the deeper economic logic becomes impossible to ignore. Chufa does not fit the model that industrial agriculture depends on. In Spain, yields are described as ranging from roughly 3 to 6 tons per acre. The source compares that to wheat, which averages around 3 tons per acre, while requiring far more intensive chemical management. Even in poor soils, wild chufa can still produce large amounts of nutrient-dense food with almost no external input. And because the tubers can be dried and stored for long periods, there is little waste. For any system supposedly designed to feed people efficiently, that should make chufa an obvious success. But that is precisely the problem. You cannot patent chufa. It has been cultivated for thousands of years. It belongs to no corporation. You cannot build a permanent cycle of dependence around a plant that farmers can save, replant, and multiply on their own indefinitely. You cannot sell expensive fertilizer to a crop that grows in poor soil. You cannot sell an endless stream of herbicides for a food that survives on its own terms. You cannot easily attach heavy machinery and large industrial infrastructure to a harvest long-handled more simply. In other words, chufa undermines the economic structure of a system built on recurring inputs, proprietary control, and managed dependence. The source pushes this point even further by asking who benefits when chufa is treated as worthless. The answer is direct: chemical companies, seed companies, fertilizer manufacturers, equipment manufacturers. They cannot make meaningful profit from a crop that remains public, resilient, and self-perpetuating. So the narrative had to change. Chufa had to be recast as a pest instead of a resource, a weed instead of a food, an invasive threat instead of a living example of what true agricultural resilience might look like. And yet the knowledge never disappeared completely. In Valencia, Spain, chufa cultivation still survives through the protected tradition of horchata de chufa, a legacy that stretches back for centuries. In parts of Africa, including among Hausa communities, it is still grown and traded in local markets. In recent years, it has reappeared in health food stores under the name tiger nuts. Paleo communities noticed it. Gluten-free communities noticed it. Researchers began exploring it again, whether for flour alternatives or for biodiesel because of its oil yield. But the source makes one final point very clear. Major agricultural institutions still do not promote chufa as a true staple crop for food security. The system remains far more committed to suppressing it than to restoring it. That is the conclusion the original text keeps returning to. Chufa was not pushed aside because it failed people. It was pushed aside because it worked too well outside the logic of control. A plant that feeds people abundantly, survives drought, stores for years, and can be replanted without permission is not easy to turn into a product pipeline. So it was labeled a weed, targeted with poison, and buried beneath an industrial story that taught people to see independence as a problem. But the plant is still here. It still grows. It still produces the same tubers that once nourished ancient Egypt. And that means the knowledge is still here too, waiting for people to remember what the system tried to make them forget.